So we're going to go through paper 2H now. Start from a nice page of algebra, so let's have a go through this. So expand and simplify. So you get a mark for expanding and a mark for simplifying. So first off, 3 times 2y is 6y, 3 times negative 5 is negative 15, 7 times y is 7y, and 7 times 2 is 14. So that's my expand bit done. So now I'm going to do my simplifying. There's 6y's and 7y's. So if I add them together, I get 13y's. I've got negative 15 as a number term and a 14 as a number term, so negative 15 add 14 gets me to negative 1. This one, right, so they've both got something in common. I've got 6x squared and I've got 15x. If I'm looking at this, they're both in the 3 times table, 6 and 15 away from me, but they're also in the x times table. What do I multiply 3x by to get 6x squared? I've got a 3 times 2 gives me 6, x times x gives me x squared. 3 times 5 gives me 15, and I've already got my x, so I've just got that. So my brackets would be 3x bracket 2x plus 5. Okay, now I know it's 2 things on the outside because I'm factorising fully. That means I've got to take more than one thing to the outside of my bracket. This one, make g the subject of the formula. So that means make it say g equals. So how am I going to get g on its own? Well, first off, I'm going to get rid of this plus 11. So I'm going to subtract 11 from both sides. So if I do that, I get f minus 11 equals 3g. To get g on its own, I'm going to divide by 3, and I get f minus 11 over 3 equals g. So that gives me g equals f minus 11 over 3. 6 marks. Nice, strong start. This one, Karen's organising a party for charity. She spends this much, so I'm going to just do that on my calculator because I'd hate to make a silly mistake by doing this. 100 plus 120 plus 80, that gives me a total of £300. So I've spent, or Karen has spent £300. Then I'm going to do 54 tickets at £7.50 each, and that gives me a total of £405. Now, exam technique tells me that whenever I type it into my calculator, I should write it down. So 54 times 750, and that gives me a total of £405. Now, even if I didn't have a calculator, if I wrote down 54 times 7.5 or 750, I'd get a mark for that. So the number is a happy coincidence. So my profit, well, I have now £405. I started with £300. So my preferred method is to do it like this. So I'm going to do 405 over 300. So I'm now going to make that over 100 because it's 100%. So I'm going to divide by 3. Divide by 3. So that gives me 135 over 100. So I've actually got 135% of what I had before. So I started off with 100%. I added on something, and now I've got 135%. So my profit is this extra bit. My profit there is 35%. My profit is 35%. Right, question 3. So compound interest. Compound interest. Now, if I'm looking at this one, I've got a formula sheet here. This is the higher formula sheet. It's written down here if you're done it in the hall and done it properly. I quite like this sort of concept. I had 100%, and I've increased by 3.4%. So I've actually got 103.4% of what I had before. Now, I'm going to turn that into a decimal, which is 1.034. 1.0. So I take my £4,500, I multiply it by 1.034 once, and then I multiply it by 1.034 a second time. So actually, I've got 4,500 times by 1.034, which is my multiplier, 2 times. And it's 2 times because I've done it for 2 years. So that's just to type it into my calculator, 1.034 squared, and that gives me an answer of £4,811.20. Next bit, solving equations with unknowns on both sides. So your teacher will bang on to you about this, but I'm going to draw my tram lines going down there. Should really have used a ruler, I'm sorry. I'm looking at this, I've got 5x on this side and I've got negative x on this side. So is it easier for me to make 5x disappear or negative x disappear? It's easier for me to make negative x disappear. So to do that, I'm going to add x to both sides. And if I do that, my left-hand side is worth 6x minus 14, and my right-hand side is worth 52. To get negative 14 to disappear, I'm going to undo that, so I'm going to the inverse of that. So I'm going to add 14 to both sides. And if I do that, I get 6x equals 66. Then I'm going to divide both sides by 6's, and I'm going to get x equals 11. Write that on my answer line, so I'm really clear for the person marking x equals 11. Right, this one, it's a really interesting question. I've got Chris, Debbie and Errol in the ratio 3 to 4 to 2. So it says Debbie gets £120. So how many lots of £4 has Debbie got to get up to £120? She's got 30 lots. So that means that Chris needs 30 lots of 3, which is £90. Errol needs 30 lots of 2, which gives me £60. So in total, if I add together their money, they've got £270 in total. £270 in total. Now, from that £270, we're now going to share it out. So we're going to share that out. So, so we're going to share £270 in the ratio 2 to 5 to 3. So that means there's 10 parts in total. So I'm going to do my 270 divided by 10. Now, I can do that in my head, so I don't need to type that into the calculator. 270 divided by 10 gives me £27. So that means Chris has got 2 lots of £27, Debbie's got 5 lots of £27, and Errol's got 3 lots of £27. So Chris has got £54, Debbie's got £135, and Errol has got £81. Chris then gives some of his money to Debbie and some of his money to Errol. How much more did Chris give? How much money did Chris give to Errol? So right, hold on. So Chris gave some of his money to Debbie, and he gave some of his money to Errol. So Errol's total has gone up because Chris has given him money. So Errol's total has gone from £60 up to £81. So Errol must have received £21. So he's received £21 from Chris. So my answer to question 5 would be a total of £21. Right, this one. So bearings. Again, it's one of those goes into that topic of we don't always teach it because it's a bit of a pain to get all the stuff out. So let's try and talk you through it. I'll do it 2 ways, and you can decide which you prefer. It says the bearing of port B from port A is 147 degrees. So that's what that picture looks like. Work out the bearing of port A from port B. So imagine I'm stood at here at B, and I face north, and I turn clockwise until I'm pointing towards point B. So I can use angles on parallel lines. I know that this is a corresponding angle. So I know that that bit there would be 147 degrees. And I know that this bit here would be 180 degrees. So my answer is 327 degrees. That's my answer. So that's one way of doing it. The other way you might want to view it is this. Well, you could say, slightly dodgy lines there, this is 147. So these are co-interior angles. So that angle there these two must add together to get 180 degrees. So that will be 33 degrees. And so the rest of it is what takes me up to 360. 360 subtract 33, and you get to 327. So either way, you're going to use an angle on parallel lines fact, but you're going to get the same answer, 327 degrees. You've just got to decide which is your preferred method. Now this one. Right, so if I'm looking at this, the circular cylinder has a radius of this and a height of this. So first off, I'm going to work out the volume of my cylinder. So the volume of my cylinder would be the area at the top, so that would be pi r squared, times by the height. So that gives me pi times 15 squared, times by the height, which is 43. So I can type that into my calculator. Pi times 15 squared times by 43. And that gives me an answer of 9675 pi. 9675 pi. So if I'm looking at that, that is the volume of my cylinder in centimetres cubed. Now there's a happy coincidence that 1 centimetre cubed is the same as 1 millilitre. 1 centimetre cubed is the same as 1 millilitre. So I'm going to try and change this unit here, instead of being in litres, into millilitres. So I know that 0.47 litres is the same as 470 millilitres. Okay, so that's a useful fact to know. So now I'm going to take my 9675 pi centimetres cubed, which is millilitres. I'm going to divide that by 470 millilitres per minute. So actually my time would be equal to that calculation. 9675 pi divided by 470, and that gets me an answer of 64.67 minutes. And that gives me 65 minutes correct to the nearest minute. Now there are other ways to do that question. I think in terms of me trying to explain it, that seems like the simplest way for me to do it. If you've done it in a different way, well done. But that's my way of doing it. Question 8. So it's rounded to 1.9. So imagine my number line. Here's 1.9. I've got a number that rounds up to it, and I've got a number that rounds down to it. So the smallest value that rounds up to 1.9 will be 1.85. Okay, and that distance there is 0.05. And I'm going to need to go the same distance down, so 0.05. So it can get as close to 1.95 as possible, as close to 1.95 as possible, but it cannot equal it. So that's why we've got this inequality symbol. Greater than or equal to 1.85, less than 1.95. Now this one, expanding triple brackets, is so easy for you to be put off by it. I'm just going to do it as two things. So I'm going to start off by doing x plus 7 multiplied by x minus 2. Now I'm a fan of the box method, so I'm always going to stick to that. If you've got a different method that will get you to the same place, by all means you go for it. So I've expanded out my brackets. Now I've got x squared. I've got 7x minus 2x, that's plus 5x, and I've got minus 14. So once I've got that, I now need to multiply all of those terms by x plus 3. All of those terms by x plus 3. So x squared times x gives me x cubed. X squared times 3 gives me 3x squared. X times 5x gives me 5x squared. 3 times 5x gives me 15x. X times negative 14 gives me negative 14x. And negative 14 times 3 gives me negative 42. So by getting myself to there, I've got 2 marks for a complete method to obtain all terms, half of which are correct. So I've got all of them. Now I'm going to collect together my like terms. So there's my x cubed term. I've got 5x squared and 3x squared, so that gives me an 8x squared in total. I've got 15x and negative 14x, that gives me plus x. And I'm going to take away 42 as well. So that would be my answer for question 9. So we're doing well so far. Right, this one, I was really proud of my Year 11s for this question. I thought it was absolutely brilliantly done, so well done them. Let's hopefully you've done as well too. So 0.87 add something gets me up to certain. So it's going to, these two numbers add together to get 1, so it's certain I will pass or fail. So those two together get me to 1. It says if he passes the first test, the probability he'll pass the second test, so pass, the second test will be 0.94. Now same logic, 0.94 add something gets me up to 1, so that's got to be 0.06. If I fail the first test, the probability I'll pass my second test is 0.73. So now what do I add to 0.73 to get me up to 1? 0.27. So that would be 2 marks for getting those numbers in the right places. Now work out the probability that Shakira passes at least one of the tests. So there's a bit of like options here. So I could work out pass. I've definitely passed. I've passed 2 tests. This one I've passed and then failed. This one I failed and then passed, and this one I failed and failed. So in terms of work, I could either work out this one, add this one, add this one and add them together, and I will get the chance of passing at least one test. But for me, that's 3 calculations, and I'm going to do it a different way, which I think is probably more efficient. So the probability of failing and then failing again would be 0.13 multiplied by 0.27. So again, can't do that off the top of my head. 0.13 times 0.27. So that gives me 0.0351. So that's the chance of me failing both of my tests, or Shakir failing both of his tests. So the chance of I not failing a test, not failing both, is the chance of everything else, because in all of the other ones I've passed one test. So I'm going to do 1 take away 0.0351. So 1 take away by answer, and I get that answer 0.9649. Now I think at least one person wrote 96.49%, which is the correct answer, or you could have written 969,649 over 10,000, but that will get the same as 2. Right, this one. So there's a few graphs that we want you to know. So we're going to start off, I'm just going to draw them along the top. So the first one is something like y equals x squared. So y equals x squared is, in its simplest way, a happy face. If I've got y equals negative x squared, I'll do that in red, that's going to be a grumpy face. So some variation thereof, that's y equals x squared. The next one we might want to do is y equals x cubed. So y equals x cubed looks some variation of that. Now you might have x squared plus 3x minus whatever, but the thing with the highest order, the power of the highest order, is the one that defines the shape. It has a great effect on the shape. So negative x cubed would look like that. If I've got y equals 1 over x, a reciprocal graph, 1 over x, you get that sort of pattern. And if you've got y equals negative 1 over x, you get the red pattern. Then you've got an exponential function. So it goes like that, and it grows like that. So it's y equals a k to the x. Now, basically, if you can recognise those ones, I reckon you're a long way to be able to do this one. So if I'm looking, do any of those look like that? Well, this one looks a bit like y equals x squared. It's just half the happy face. So y equals x squared, so that's D. Y equals x, so we haven't done that. Or y equals 1 over x, we've got that, so that's, which one of those is that? That's B. Right, y equals x. Well, we don't often see this one as much, but if I've got y equals, if I've got y equals x, it looks like that. Y equals 2x looks like that. Y equals 3x looks like that. So which one of those does that look most like? That's going to look like A. And y, therefore, by process of elimination, I get y is proportional to the square root of x. I've used A, B, and D, so that's going to have to be C. This one. I always think having a diagram helps me understand. So here's my diagram. It's very rough. It is just a sketch. That is point A, 7, 13. Point B is at negative 3, 21. So that's point B. So roughly speaking, it was very rough. And C is 15. So it's over here and up there. So there's C. So that's my diagram. M is the midpoint of AB. So M is going to be somewhere along this line. N is the midpoint of this line, so N is going to be up here somewhere. So we've got to sort of try and work them out. Now you get a mark for either working out the coordinates of M or N. So I know that M is halfway between these 2 points. So what I'm going to do is I'm going to do 7, add negative 3, divided by 2. So 7, add negative 3, divided by 2. And I'm going to do 13, add 21, divided by 2. So that will give me the coordinates of M. That will give me the coordinates of M. So if I've got that, 7 add negative 3 is 4. 4 divided by 2 is 2. 13 add 21 is 34. Divided by 2 gives me 17. So if I just wrote down 217 and stopped I'd get 1 mark for that question. So everyone in doing this paper, I think, will be able to find at least that one. Or you could have made a mistake on that one, so let's do the same thing for n. -3 add 15 divided by 2. 21 add 23 divided by 2. So that gives me -3 add 15 is 12, divided by 2 is 6. Oh, and this one, 21 add 23 is 44, divided by 2 is 22. So 622. Now, if I wanted to work out the distance between those two things, I've actually gone from 2 to 6, so I've gone 4 units to the right, and I've gone from 17 up to 22, and I've gone 5 units up. Now, I'm trying to work out that distance, and whoa, I've turned this into a Pythagoras question. Because I know that the distance x squared is equal to 4 squared plus 5 squared. So I'm fairly confident with my square numbers, so I've got 16 plus 25. So I know that x squared is worth 41. And so x would be the square root of 41. Now I don't know that one, so I'm going to do square root of 41, type into my calculator, and that gives me approximately 6.4. So my answer there would be 6.4. And really I'm finding the averages of numbers. I'm using Pythagoras, but it's a bit hidden, so we just need to get you into that habit of finding it. This one, prove algebraically that this is the case. Right. I've got a dot on my first digit that recurs, I've got a dot on my last digit that recurs. So 7's recurring, 2's recurring, and 3's recurring. So that means that 3 digits are recurring. So if x is 0.0723, oh sorry, I don't need that, cross that out. 3 digits are recurring, so I need to multiply that by something to move it 3 places across. So I'm going to multiply that by 1,000. So if I multiply that by 1,000, my 7 is going to go 1, 2, 3 places across. My 2 is going to go 1, 2, 3 places across. My 3 is going to go 1, 2, 3 places across. And then because it's recurring, there's going to be an infinite number of them fill in the gaps. So if I subtract 1,000x, subtract 1x, that gives me 999 x's. These 3's cancel, these 2's cancel, these 7's cancel. 3 subtract 0 is 3. 2 subtract 0 is 2, and 7 subtract 0 is 7. So that tells me that 1x is that 72.3 split 999 ways. Now, I don't like the fact that there is a decimal in my fraction, so I'm going to times the top by 10, my numerator by 10, and my denominator by 10, and that gets me to 723 over 9,990. Now, because they're both in the 3 times table, I can divide them both by 3. I don't expect you to suddenly be able to just do that stuff. I could just type it into my calculator, 72.3 over 999, and you'll see that my calculator will turn it into 241 over 330, 3330, sorry, but it's also written there, so that's what I'm trying to prove, which I have done. This one. I was very, very impressed with my class for doing this. Y is proportional to x squared. Now that is not a mark. Let me just confirm the marks I've got here. Y is proportional. No, so I haven't got a mark yet. And the other one is x is inversely proportional to w. So I haven't got a mark, but I've got a concept. Now what I do know is that y is equal to a number, call that k1, times x squared. Now just for writing that down, you get a mark. Or, for writing this one down, you get a mark. So what either of those things, there's no excuse for anyone in this watching this video to not get one of those marks. Then it tells me a pair of values. So when y is 3, x is a half. So 3 is equal to k1 times a half squared. So how do I get rid of times in by a half squared? I'm going to divide both sides by a half squared. So I'm going to type that into my calculator. 3 divided by 0.5 squared. And that gives me that is worth 12. So I now know that k is 12. So I'm going to write this equation, y equals 12 times x squared. And for getting to there, I've got a mark. If I wanted to do it on this side, I've got when x is 2, w is worth 0.2. So I'm going to work out K2. So how do I get rid of dividing by 0.2? I'm going to multiply both sides by 0.2. So I know that K2 is worth 0.4. So I now know that X is equal to 0.4 over W. Yeah, exactly the same thing. Now, one person said on their test, how do these things get linked together? Well, this one's got an X in it, and this one's got an X in it as well. So I'm going to put this X into this equation. So now I'm going to write Y is equal to 12 lots of X, which is 0.4 over W squared. Okay, and for writing that bit down, I've now got myself my third mark. And that's 12 lots of 0.4 over, this is when W is equal to 2 squared. So I'm just going to type that into my calculator because I can. 12 multiplied by brackets, 0.4 over 2 squared, and that gives me 0.48. Okay. So if you think about my marks there, you get 1 for that, all that. You get 1 for working out for coming up with this equation, or K is 12, or W is K2 is 0.4. You get 1 for coming up with this equation, where you combine the two things. You get 1 for substituting into that equation, and then you've got your last mark for filling in the numbers. Right, this one, histograms. Now, histograms, I'm convinced people think they're more complicated than they are. I'm just going to sort of talk you through how I look at a histogram. It is a bar chart, but the big thing for me is that instead of the height of the bar being the frequency, the area of the bar is the frequency. So frequency density, which is coming up the side here, frequency density, times by my class width, will get me to frequency. So I'm just going to give myself a little bit of calculation space here. I'm just going to add myself some extra columns. I've got class width and I've got frequency density, because I'm going to fill these things in a minute. So I know that the class width goes from 10 to 12, so that's 2. This one goes from 12 to 16, so that's 4. This one from 16 to 19, so that's 3. This one from 19 to 21, so that's 2. This one from 21 to 26, that's 5. The frequency densities, well, some of them I've actually got. Well, no, I haven't, because I haven't got any frequency densities on here. But I know that this bar here has got an area of 10, and this bar here has got an area of 15. And I know that this bar is 4 units wide. So if it was just an area question, and this said 10, and this said 4, how tall would that need to be? It would need to be 2.5 tall, so that bit there must be 2.5. That bit must be 2.5. Now if that's 2.5, then that's 1, 2, 3, 4, 5 of these larger boxes. So actually, these larger boxes are going up in 0.5s, 3.5, 4, 4.5, 5. So I've got that bit. Now I can just do some calculations. So this one is 2 units wide and it's 1.4 units, 1.5 units tall. So it's 2 units wide and 1.5 units tall. So that will give me a frequency of 3. 2 times 1.5. This one, it's 3 times 5, which gives me 15. That's good. So this one, 2 times something gets me to 9. So that's going to be 4.5. So 2 times 4.5 gets me to 9. And last one, 5 times something gets me to 7. So 7 divided by 5 gets me to 1.4. So now I've got all the information, I just need to put it on the diagram. I've got this point here going up to 4.5, so it's should really be reaching for a ruler. So it goes 4.5 wide and it's 2 units. So that gets me to there. This one, it is 1.4 units tall and it takes me up to 26. I'm hoping is there, 26. There you go, and that is my completed histogram. So that's 3 marks for getting to there. Now, next one, the histogram gives an illustration taken by 43 students to run a different race. Now, we are not trying to confuse you, we're not trying to make this difficult. there is such an easy mark on this question. So if you've got 43 students and we're trying to find the middle one, so I'm going to say, right, 43, well, if I do 43 add 1, that gets me to 44, divided by 2. So my middle student would be my 22nd student. My middle student would be a 22nd student. So I would get a mark just for doing that bit. And I think that is a relatively easy mark when you consider we're on question 15. So I now know I've got to get 22 students. So, well, this one, so I've got 2 units wide, and it goes up to 2. So 2 times 2, that will get me to 4. So I'm not in the right place. So 2 units wide, and it goes up to frequency density is 2. This one takes me from 12 to 16, so it's 4 units wide, and it goes up to 2. 4 times 2 gets me to 8. This one is also 4 units wide, and it goes up to goes up to 4, so 4 times 4 is 16. This one is 2 units wide, and it goes up to 6.5, so 2 times 6.5 gets me to 13. And last one, this takes me from 22 up to 26, so it's 4 units wide, and it takes me up a half, so 4 times a half gets me to 2. So my histogram there would be worth 2. Even if I've just written down for finding an area of at least 2 of those bars, if I could find those areas, I get 1 mark. So for 2 of those areas, I get 1 mark. So I'm trying to find the 22nd value going across here. So I've got 4, and I've got 8. So that's, so far I'm up to 12, but I'm trying to get to 22. So I need another 10, don't I? I need to go 10. So I want to go 10. I don't want to go all the way across here. I just want to go 10. So how am I going to figure out how far to go? Because if the whole box is worth 16, I want to find a way of cutting that box into a smaller section. So I'm going to try and cut that box into 10 and 6. Yeah, so that's what I'm trying to split it. So hopefully you realise I want 10/16 of that distance. 10/16 of that distance. So the width of my bar is 4. So if I go 10/16 of 4, 10/16 of 4, then that gives me 2.5. So that gives me 2.5. So I want to go 2.5 seconds further through this set. So that set there starts at 16, and I want to go 2.5 seconds through. So I'm going to go 16 plus 2.5, and that gets me to 18.5 seconds. Now, that might not be the right answer because it might not be distributed evenly across that bar, but if I had to predict, that seems a really sensible prediction. I'm going 5/8 of the way across that bar, so my 25th value, my 22nd value, sorry, would be there. There's my 10, and there's my 6. Okay, so that is my prediction of an answer, which is 18.5. Well, done. Next one. Okay, so I am talking very fast. Remember, you can pause me. I can't pause myself. You can pause me. Right, spot on. So we're going to try and work out the area of this triangle BCD. So we're trying to work out the area of this triangle here. Now, things I know. Well, I've got some parallel lines. So I know that if this angle here and this angle here are the same, because they're alternate angles and they're equal, I know that that angle there must be 42 degrees. So I know that must be the case. So I now know this length and I know this angle. So if I could work out this length, I'm absolutely sorted. So I'm going to look back to this triangle. Well, can't use trigonometry because I haven't got any right angles. I can use the sine rule because I've got a length and its corresponding side. So I can use the sine rule. That's good. So I'm going to have a think about what the sine rule is. If you can, try and use the sine rule. So here's my sine rule written on my formula sheet. A over sine A, B equals sine B, B over sine B. Now I do actually want a length, so I want lengths on the top. So if that's D, capital D, this is going to be lowercase d. And this is A, so this is lowercase a. So I'm going to say that A over sine A is equal to d over sine d. So I know that a over sine 112 is equal to 7.9 over sine 42. Now, just for writing that down, I would get a mark. Now I'm going to solve it. So to get rid of divide by sine 112, I'm going to multiply both sides by sine 112. So here we go. 7.9 over sine 42 multiplied by sine 112. So I know that A is approximately 10.94666777. So that is my length of A. But I'm just going to remember that's in my calculator. So now the area of any triangle, let's find my formula sheet again. Area of any triangle is half AB sine C. So I've got that. So I've got half of A times B times sine the angle in between. So I'm going to do area equals half times the number I've just got times 15.3 times sine 42. So I'm going to type that in, a half times answer times 15.3 times sine 42. And if I type that in, my area is 56.0343565 centimetres squared. It says give your answer correct to one decimal place. So there's my box. Does 3 cause me to add 0 or 1? It causes me to add 0. So I've got 56.0 as my answer, 56.0 degrees on my formula sheet, and we're sorted. Question 17. Now, this is give me marks. This is give me marks. Question 17, and I promise you, like, once we've been through this, you'll think, is that all I needed? It tells me the equation is between, so that equals 0 is between x equals 1 and x equals 2. So if I put x equals 1 into this equation, I get 1 cubed plus 2 times 1 minus 6. So 1 cubed is, I'm going to type into my calculator just because I'm being really lazy, plus 2 times 1, take away 6. So that gives me an answer of negative 3. Now I don't want negative 3, I want 0. But let's try the next one. If I put x equals 2 in there, I get 2 cubed plus 2 times 2 minus 6. If I do that in my calculator, 2 cubed plus 2 times 2 minus 6, that gives me an answer of 6. So let's look at that. When I put 0 in, when I put 1 in, my answer is negative 3. When I put 2 in, my answer is 6, but I want my answer to be 0. So my answer's got to be bigger than 1, and it's got to be less than 2. So I've actually proved it just by substituting into those two values. That is not a bad way to be able to pick up marks if that comes up again. Right, this bit, I've got to rearrange this to give this. So first off, I'm going to try and make it look like this, so I'm going to add 6 to both sides. So if I add 6 to both sides, I'll get x cubed plus 2x equals 6. Now that looks, I'm looking good, but it doesn't look exactly the same. Now these two have both got x in them, so I'm going to factorise it. And now I've got that, x times that gives me 6. So hold on, if I divide both sides by x squared plus 2, we're sorted. Look at that. Proved it. That is the same as that. We're absolutely golden. This one, there's one boy wrote a little note on, I think, the previous page saying my calculator stopped working on this bit. I do feel for you. He perfectly wrote down what to do. He basically wrote, write 1.5 into your calculator and press equals. And then you're going to type into your calculator 6 over answer squared plus 2. Press equals and then press equals again. That's what he wrote down, and he's absolutely correct. And annoyingly, I couldn't give him all the marks because it says give your answer to 4 different places, which he did not. But do I say your name? Harrison. Yeah, Harrison. Well done. You knew exactly what to do. Unfortunately, just put your hand up and say, my calculator's broken. Help me, please. So we've got this 1.45 into my calculator and press equals. So then I'm going to type this into my calculator. So I'm going to go 6 over answer squared plus 2. So I just type that into my calculator. 6 over answer squared plus 2. And if I press equals once, so x1 must be worth 800 over 547. And I press it again, x2 equals 1.449634937. 1.449634937. And it says give your answer to 4 decimal places. So there's my 4 decimal places. Does 3 cause me to add 0 or 1? It causes me to add 0. So my answer would be 1.4496. 1.4496. And again, I've written my answer on the number line, making it really easy for the person to give me marks. Right, this one. So I was a bit disappointed by some people's effort to have a go at this. There's some really easy marks on here. A to H. So go down here as A, and that's the midpoint. So that's also A. That's A. That's A. A to E is B, and E to B is B as well. And D to G, that's C, and this one's C. So I've got all of those things. Now I'm trying to work with this parallelogram. And the way I'm going to try and prove that it's a parallelogram is I'm going to prove that E to H is the same as F to G. If I can prove they're the same, and I can also prove that E to F is the same as H to G, then I can prove that they are parallel and they're the same. So two pairs of parallel sides that are the same, they've got to be a parallelogram. Okay, so that we're trying to work to this point. So first off, I'm going to work out what E to H is. Oh, sorry, E to H. So I'm trying to go from here to here. So I'm going to have to go, I can't go direct because I don't know what that's called. So I'm going to need to go backwards along B and forwards along A. So backwards along B and forwards along A. And that gets me a mark, just for writing that down. That is 1 mark. So next bit, I'm going to try and work out from F to G. Well, F to G. So we're going to need to do some thinking first. Right, so what am I going to do? I'm going to do from F to G. Well, I know that I'm going to go from, let's work out, let's be a bit more systematic. Sorry, I do apologise. I've started in a bit of a funny way. So if I wanted to go from B to C, I need to go backwards twice along B, and I need to go, can you see that? And I need to go forwards twice along A, and I need to go up C twice. So that is how I go from B to C, twice that way, twice that way, twice that way. If I wanted to go from B to F, that's half that distance, So B to F is going to be negative 1B plus 1A plus 1C. Okay. And because that's the midpoint, from F to C is going to be negative B plus A plus C. It's going to be the same again. Okay, so let's just think about how I've done that. B to C is all the way around the outside. B to F is halfway along that, so it's just half of it. And F to C is the other half, the same again. So those two things are equal. Now, if I wanted to go from F to G, well, I'm going to do F to C, which is that thing I've just got, and then I'm going to go backwards along C. So if I wanted to go from F to G, actually these two things just cancel out, so I'm going to be left with negative B plus A. So I've got F to G is negative B plus A. Well, hold on, there you go, that is the same as that. Perfect. This is looking good. Right, now I've got to prove H to G. So, right, well, let's, where should I write this? I'll stay up here. So I know B to F. So if I'm trying to go from E to F, so here to here, well, I know I'm going to go along B, so up there, and then I'm going to go down this bit, minus b plus a plus c. So now b minus b, they cancel off, so e to f is just a plus c. Okay, e to f is just a plus c. And let's now prove that's the same as h to g. So we're going to get a plus c. So now I've proved it because I know that e to f is the same as e to f is a plus c and h to g is a plus c. I know that e to h is negative b plus a and f to g is negative b plus a. So I've actually proved that must be a parallelogram. However, the thing that annoys me is there's lots of people here who've not tried anything. If you just wrote a list of things you do know, what is it from e to h, what is it from here, you would get marks. So here on the mark scheme, like the person marking your paper will see if you've got e to h or h to e or h to g or g to h or b to c or c to b or e to f or f to e or f to g or g to f, and they've got expanded forms and simplified forms. So there's things that they are looking for, and you can get 1 mark for having any of these things. So please, 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 if you're not sure, just write something down, and hopefully the person marking your exam will be able to give you some marks for it. This one, right. So I'm going to try and work from my inside to out. So first off, I'm going to work out f of negative 3. So I can't work out g of f of negative 3 until I've worked out f of negative 3. So that means I'm going to put negative 3 into this thing. So where it says x, I'm going to write negative 3. So I'm going to do 2 times negative 3 plus 3 squared. So that gives me negative 6 plus 3 squared, which gives me negative 3 squared, which is 9. So I know that f of negative 3 is worth 9. And if I wrote that down, I would get a mark. No, I wouldn't, but I'd almost get a mark. And then I need to take that thing, I need to take g of f of negative 3, or that's the same as saying g of 9, because I know that f of negative 3 is 9. So I'm going to take that and I'm going to put it into here. So I do 2 times 9, take away 1, and that gives me an answer of 17. Now one person did all of this, and then they added 1 rather than subtracted 1. So I do feel really sorry for that person because they've done all the hard bit, but it's really important that we pay attention to these things. Right, inverse functions. Like there's sort of different ways to explain it. I just think having a flow chart sort of makes sense. I've got this machine called G. It takes x, it multiplies it by 2, and it subtracts 1, and you get g of x. There you go, done. If I put x into the other end of that machine, if I put x into this end of the machine, what would I need to do to it to get out? So I'd need to add 1. Once I've done that, I'm going to need to divide by 2, and that will give me the inverse of g, undoing that function. So I take x, I add 1, and I divide it all by 2. There you go. That is definitely worth a go at. Next time you see an inverse of a function, have a go. Right, this one. So there are loads of things that you can do to go wrong on the question like this, but we are looking at the penultimate question, so it's not supposed to be super easy. The first thing I want to do is I want to factorise this thing. So I'm looking for things that multiply together to get 112 and also add together to get negative 6. So 112 is 2 times negative 56, add together to get 6. So I've got 2x squared up here, I've got negative 56 in here. So things that multiply together to get 112. So I've got 1 times 112, 2 times 56, 4 times 28, 8 times 14, 14 times 8, 28 times 4, 56 times 2, and 112 times 1. Now because it's negative 112, I want one of these things to be a negative. So got that, so one of those is going to be a negative. The pair that adds together to get negative 6 is this one. So in these two boxes I'm going to put negative 14x and plus 8x. So now what times table are these in? They're both in the 2x times table. 2x times x gets me to 2x squared, 2x times negative 7 gets me to negative 14x, x times 8 gets me to 8x, and my two brackets would be 2x plus 8 and x minus 7. So 2x plus 8 and x minus 7. We will be back with that in a minute. So I've got 14 over, now I can actually factorise this thing here, 3 lots of x minus 7, plus, and then I've got some big brackets here, x plus 4. Now there's a really easy mark. If I'm dividing by a fraction, it's the same as multiplying by that fraction's inverse. So that would give me 2x plus 3 over, and I've just factorised that, I get 2x plus 8 over x minus 7. Now at this stage, well, I can realise that these things here they're both in the 2 times table, so when I do my next step, I'm going to change that to 2 lots of x plus 4 because I can. So I'm now going to write this out again. I've got 14 over 3x minus 7 plus, and then I get this fraction, x plus 4 multiplied by 2x plus 3 all over 2 lots of x plus 4 times x minus 7. Okay, so I've got that. Now what can I cancel? Well, actually I've got an x plus 4 and an x plus 4, so they can cancel off. So I've got 14 over 3 lots of x minus 7 plus 2x plus 3 over 2 lots of x minus 7. So there are different ways to do this. But I'm just going to make my denominator, my bottom number, 6 lots of x minus 7. So how do I make that into 6 lots of x minus 7? Well, I'm going to multiply my first fraction by 2 on the top and the bottom, so that's going to give me 28 lots of, just 28 on the top. And this one I'm going to need to multiply that by 3, so that's going to give me 3 lots of 2x, which is 6x, and 3 lots of 3, which is 9. So then I've got, my denominator stays the same, 6 lots of x minus 7, and my numerator is 6x plus 37. 6x plus 37. So just check I've done that correctly. Phew. So 6x plus 37 over 6x, oh hold on, so it's not quite in that format. Sorry, I've done it, but I've not been really careful because it needs to be in that format, so it needs to be cx plus d. And at the moment I've got some brackets, so I'm just going to rewrite that 6x plus 37 over 6x minus 42. So I've just got to expand out those brackets. So it was worth me checking because now it's in the right format and I would get myself full marks. If I hadn't done that, I would lose a mark. Last one, nearly there. We are going to have a go at this. Vicky's taking a random, probably is a gold, right, given that it is gold, so B is gold medal, so this is how many gold medals I've got. Now, everyone watching this video, if you haven't stopped, there is a really nice, easy mark for this. How many gold medals are there? Well, there's 5x minus 3 just gold medals, and there's X medals which are gold and English. So the total number of gold medals is 6x minus 3. And you get a mark for writing that down. Okay, so even on our last question, all of our higher students should be having a go at that because that is an easy mark. Now it gets a bit more complicated. Given that the medal is gold, the probability that it's English is 2/11. So, right, so given that it's gold, so my denominator's got to be 6x minus 3. The chance of it being English is 5x minus, it's English is x. So English gold, so it would be x over x minus 3, 6x minus 3. And that gives me 2/11. So I've got 2 marks now for doing relatively little. Yeah, this is how many golds there are. These are of the golds, how many are English. So now I'm going to cross multiply. I'm going to do 11 times x, and I'm going to do 2 lots of x minus 3. So that gives me 11x is 12x minus 6. So I'm going to add 6 to both sides. 11x plus 6 equals 12x, and subtract 11x from both sides of x is worth 6. Right, so now I've got x is worth 6. Work out the total number of medals in Vicky's collection. So Vicky has got 7 lots of 6 minus 11, which is 42 minus 11, which is 31. Now, I'm confident with my arithmetic, but I'm also thinking I don't want to do something stupid at the very end of a paper and mess it up. So 7 times 6 minus 11 is 31. I've just got 6. I've got 5 lots of 6 minus 3. 5 lots of 6 minus 3, that's 30 minus 3, 27. And I've got 34 on the outside. So if I add all of them together, 31 plus 6 plus 27 plus 34, that gives me a total of 98. So the total number of medals is 98, and the total number of marks, therefore, for you is 80. Boom, full marks. Well done. You've nailed that paper.